Okay, sorry about that. All right, so here's the example. Let's take f of x equals natural log of x, or 1 plus x, centered at 0. And we've written the series before, and I'm just going to take the first two terms. So let's say this is our series, x minus x squared over 2. No more terms, cutting it off there. So second degree polynomial, or even a second partial sum, just only two of the first two terms. And the question says, find the error when x is between negative 0.1 and 0.1. So here's my remainder formula, just copied from the board to the left. If this is my remainder formula, the first thing I want to understand is the n that's with the r refers to the degree of your polynomial. So if my polynomial had a degree of 2, this means this is my remainder for a polynomial that was degree 2. Because that's going to matter. Depending on how many terms I picked is going to change what I'm looking at as far as the remainder. So I only picked a second degree. My remainder is called r sub 2. Well, if my remainder is called r sub 2, then that defines what the rest of my terms are going to look like. Because up here, in the main formula, I know it's n plus 1, n plus 1, n plus 1. Well, the n is 2, because the degree of the series, the highest degree of the series is 2. So my remainder for a series that's to the second degree is going to be the third derivative of f at some point c times x minus 0 to the third, again 0 because it's centered at 0, over 3 factorial. Okay, get it? Yes, we get it. Okay, so I am just simply trying to plug stuff into this formula to figure out what the remainder is. Well, I already knew it was centered at 0, that was easy. And I know it's 3 factorial, but I got to figure out what x value to put in and what to put in for this third derivative of f at c. Well, the x value, I'm given a range of x values. I'm looking at x values from negative 0.1 to 0.1. Which one do you pick? Here's an important idea. The number that you pick is the number that's going to give you the biggest error that you can possibly get. You always want to estimate to the biggest amount that you can. So, since my interval is from negative 0.1 to 0.1, I'm going to pick my x value to be 0.1 because I want my biggest possible amount of error. So I'm going to pick the biggest x value. So I'm going to put 0.1 into this formula for x. The tricky part is figuring out what to put in for the third derivative of c, or the third derivative of f at c. So let's go over to this part. First we have to find the third derivative. So the first derivative of the natural log of 1 plus x is there, second derivative, third derivative. Okay, I have the third derivative. Here it is, and then I rewrote it in fraction form. Well, I need to figure out what is that third derivative evaluated at some x value between negative 0.1 and 0.1. The x value that I pick is important. I'm going to use negative 0.1 for my x value because that's going to produce the largest y value and therefore the largest possible error. So let me go back to that. If this is my third derivative looks like this if I went and graphed it. Well, 0.1 gives me a y value here, and negative 0.1 gives me a y value that's bigger. I don't even have to know the graph. I could just kind of plug some stuff in and see what x value gives me the biggest number for this third derivative. And I can see from the graph that negative 0.1 is going to give me the biggest y value in the third derivative of f. So I'm going to choose x equals negative 0.1 to plug into this thing, and it's going to give me the third derivative at some point c. Remember, my point c was a number between where it's centered and the x value that they're giving you. So I'm picking negative 0.1 as that number because it gives me the biggest possible value for that third derivative. So I hope that makes sense. So therefore, I'm picking x equals 0.1 up here because that's going to give me the biggest possible error. I could pick x equals negative 0.1 also, it really wouldn't matter. And then for the third derivative, I'm picking x equals negative 0.1 because that's going to give me the biggest value for the third derivative. So I take those numbers back over to the remainder equation. Here's the formula for the remainder. I said x was 0.1, and I said third derivative of f at c, we just found is the 2.7 for blah blah. Put it all together, and you get, drum roll, blah, 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 there. That's it. That is the error of the Taylor polynomial for natural log of 1 plus x. That's a second degree polynomial. That is the error when x is between negative 0.1 and 0.1. Now yes, the error is smaller at x equals 0. And maybe there's no error at x equals 0. But the biggest possible error on that interval is 0.000457. One other small note, when you calculate this error on your calculator, if you're going to round, which at some point you're going to have to, round up every time. Don't truncate, don't follow rounding rules, just round up. I don't remember what I actually got here when I did it on the calculator. Maybe it was 0.000456 or whatever. Round it up, round that last number up every time. Okay, that's it. I hope you had fun, and I will update the Ning, and I'm sure everyone will be happy. Bye!